In this video, I'm going to cover how you can turn vodka into almost 100% ethanol. And to start, I'm going to go over the setup to do this, and that I think is the best way to do it. So I have a round bottom flask here. It's on top of a heater, and that's connected to what's called a fractionated column. And we'll go over that in a second, what that means. And then this is connected, you can't see it, to the actual tube here that distills the ethanol in this case into this somewhat smaller round bottom flask. And this is sealed completely. All the joints are sealed so that this is a closed system. The only open part is a small vent hole that's at the very end here where you can put a vent hole without affecting the entire process in case pressure builds up. It's got a way out. So the round bottom flask is pretty straightforward, but the fractionated column here is what I'm going to focus on a little bit. You can see try to enlarge this like a magnifying glass here. And essentially it's a glass tube that has what looks like you took a hot poker and pushed the glass into the inside of the column here. And it leads to what looks like a bunch of glass fingers on the inside here. And to show you more clearly, I have the one I used here. And it's kind of hard to tell by looking at this, but you can see how there's a hole here. And then if you look down that hole, it's hollow. And on the inside, it gets pushed to a point here. And there's one here. They're scattered in a pattern here, but they go up and down the entire tube here. So that's what this is right here. And the reason you use a fractionated column in this situation is because alcohol and water form an azeotropic bond. So what's an azeotropic bond? It's when two or more liquids are mixed together and they have the same concentration, both liquids, when they're in the liquid and in the vapor phase. What that means in real life is that when you're trying to separate ethanol from water, they want to come up together and they want to distill over together. And so you end up with water coming over with your ethanol, which is what you don't want to have happen. And the fractionated column helps solve that problem because as these heat up, these little fingers here, as the vapor rises from the vodka, which is water and alcohol mixed together, or ethanol, they will start to collect on their tips both water and alcohol. But over time, because ethanol has a lower boiling point, it will make its way all the way to the top before the water will. And when it does that, it comes over, because this is sealed here, it comes over here to the distill tube, and there is water, cold water, coming down, goes into the tube here, fills up the tube, and then it comes out here into a bucket usually. And that cold water turns this vapor, which is mostly ethanol at this point because it made it all the way up this fractionated tube, turns the vapor into a liquid. So as that vapor travels down here, it gets cooled by the circulating water here, and eventually it starts to collect into little drops here and comes down the end and drips in here. The process doesn't take that long, but it's not quick, that's for sure. One last comment I want to make here, and that's the thermometer right here, which is this white line that enters the top of the column, this entire column right here, and it's sealed with a rubber grommet here, which keeps the outside air from getting in, and vice versa. And the bulb of that thermometer sits right at the point where the vapors accumulate and before they start to come over into the distill tube here. So you get an accurate reading of what's actually surrounding this area here around the bulb of the thermometer. So ethanol has a boiling point of 78 degrees Celsius. The thermometer I'm using happens to be Celsius, or 173 degrees Fahrenheit. Water is 100 degrees Celsius boiling point, or 212 degrees Fahrenheit. We all pretty much know that. So as soon as these two start coming up and the ethanol makes it all the way to the top by itself through the fractionated column and starts to come over here, your thermometer will read at 78 degrees, or very close to it. And eventually, though, as you heat the volume down here of the vodka, water will start to make its way up this fractionated column eventually, and it'll hit the bulb of the thermometer. And when that happens, the 78 degrees is exceeded, and you'll see it climb to 79, 80, and so on and so forth. And if you kept it up, eventually you would get rid of everything here, and you'd have vodka back in this one. The same thing you started with. So the idea is to stop the heat when the ethanol, the 78 degrees, is exceeded at the bulb of the thermometer right here. And if you do that, you should get almost pure ethanol. Sometimes a little water will make it over, but it's pretty much good for anything you'd want to use in a lab. So we're set up here for another distillation. I just turned the heat on. That's vodka, and just plain clear vodka. And again, the fractional distillation column is set up so that as the alcohol makes its way up bit by bit by bit, because its boiling temperature is lower than water, which is the only other thing in there, the water will drip back down and the alcohol will eventually drip over here and end up here. And again, that's ethanol that will be drawing out of there. So it just started. We'll wait for it to heat up and see how it goes here. So we have some ethanol dripping over nicely on this end. Everything else is working well. Got our vodka down there. You can clearly see the waves of heat running through it. And fractional distillation column working great. And then you can see up here that the temperature is around 80. You kind of see it right there. The boiling point of ethanol is right there. 78 degrees. So that's what we're looking for. As soon as it goes above 78, I know I'm starting to get some water, and I'll turn it off. Okay. As the ethanol is distilling over, you can see it happen in a way. You can see sort of the wavy lines through the middle tube of the distiller here. And as you go along, you can still see them, but they become a little bit smaller as more and more ethanol accumulates, and then eventually the ethanol is heavy enough just to fall to the bottom and come over and drip. So there you have it. Kind of interesting to watch. Also, this is a liter. So I would say I filled it up about 2/3, and 40% of that is alcohol. As it turns out, the vodka is 40%. So 2/3 is around 600 to 700, let's say 600 milliliters went in there, and 40% of that would be 240 milliliters. So in the end, we should have about 240. This is a 500 milliliter flask, so there should be about half of this filled with the ethanol. Well, we're coming up to almost 500 milliliters on this flask here. I'm sorry, 250, and 240 would be the calculated amount approximately that would come over. So we're real close here. We're still at the 82. Gosh, this is terrible looking through this thing here, but you can't see it. We're at about 80, 81, sometimes 82 on the thermometer. So it's still ethanol coming over, but we're close. You can see that the temperature's starting to creep up there. It's at about 80. Well, you gotta trust me on this. Well, actually it's almost 90. So at this point there's a great deal of water coming over. It's not all water. So I stopped it and pulled off the flask. So here we have it. This is probably 95 plus, probably closer to 98% pure ethanol, basically poison at this point. If you touch this to your lips, it burns, so there's no way you could even drink it. But that's not the point. It's to be used for other experiments. So, all right, that's it.